a concept check, and then any questions you may want to ask or you have. Exponential functions have, this was a question mark, have how many shapes?
2.
Yes, thank you so much. As you see, I changed it into a question mark because I already wrote it by mistake. Good. One that is doing something something and the other one that is doing what?
Increasing.
Yes, one is increasing and the other one is decreasing. This has base greater than 1, and this one has base tiny between 0 and 1. Not 0, not 1. Awesome, thank you. Great job. Exponential and log functions are?
Inverses.
Thank you very much. The following numbers cannot be the base of an exponential or log.
0 and negative 1 or 1?
Yes, 0, negative, and 1. Exactly. 0, 1, or negative. Awesome. Thank you. 0, 1, negative number. Exponential functions have this domain and this range. Log functions have this domain and this range.
I think exponential is negative infinity to infinity.
Yes, and always remember, always here. That's how it goes.
And then for log, would it be domain of 0 to infinity?
Yep, because this is 0 to infinity. This must be 0 to infinity. Good. The conversion between log equation and exponential equation.
A raised to y equals x.
That's it. Thank you so much. Great job. Awesome. Any questions on these? I'm just making sure that my camera is okay. Good. Continuous compound interest formula.
Oh, principal times
Euler's number.
plus
Euler's number. Good.
number, and then n to the
There is no n because it's continuously, so just the interest rate times t. The interest rate times t. It's continuously compound interest. So E, we already said, it's Euler's number. Properties of log.
A times B equals log A plus log B.
That's it.
A divided by B equals log A minus log B.
Excellent. And the last one, let's say A to a little power, whatever the power is. This number goes in front as a factor. By factor, we mean multiplication, not addition, subtraction, division.
Would it be b log a?
That's it. Awesome. Thank you so much. Awesome. Change of base formula. So if I have log base A of x, one or the other. You don't have to do both, but I would like to write both.
would it be x log of a?
You mean log x over log A. Log of the number over log of the previous base. They are not the same. Not to be confused. This is log applied to a ratio. This is the ratio of two logs. And what is the other option? It's only because we have them in the calculator. That's why I would like to write both options.
ln x, then ln a.
That's it. Good. When solving log equations, we either or one of them, it's a must. If you don't like this, you do this. I like this because it's easier for me, but it's up to you. So when we solve log equations, we have to do either A or B. Always and forever. Okay, let's go back. Or, so we find the domain, or we promise to what? You may have said it, I didn't hear it, sorry.
Would it be find the domain or find the range?
Or check in the original problem. I think that this is more difficult in easy situations. So going back just for a second to clarify this. If I hadn't stated restrictions here, so let's say I don't state restrictions, and then I get two solutions on the next page, sorry. On the next page, I got plus or minus 4. I have to go back here and say 4 plus 3, that's natural log 7. 4 minus 3 is 1. Natural log 1 is 0. Log 7 is log 7. Awesome. Now I have to check negative 4. Natural log of negative 1 does not exist, so negative 4 cannot be accepted as a solution. I stated the restrictions. I didn't have to do that. I looked at the domain and I said 4 works because it's here. Negative 4 does not. And that was it. So you must choose one or the other. Nobody's forcing you to use the domain. Nobody's forcing you to check. It's up to you. But you have to choose one or the other. You either find the domain and then you say, okay, whatever I got is in the domain, accepted. If it's not, not accepted. Or you check back in the original problem. And then you state it works or it doesn't. Good. Any questions? Any questions before we continue? Any questions for me? Okay, so as I mentioned before at the beginning of the class, but not everyone was here. So we only look at 3 sections in chapter 2. So we're going to look now at 2.2 and 2.3 because this is what we are interested in. This was all algebra. There was no calculus here. This is all review from your previous experience with log and exponentials. This is what we are really interested in. So this was just a review. So here we're going to talk about the derivatives. Exponentials and log functions. So the easiest function to work with and find the derivative is this. Yep, you may not believe it, but that's true. The derivative of e to the x is e to the x. Can it be easier than that? But now, if I want to differentiate e to a function, the function is not plain x. the function, like for example, could be 2x cubed plus 4. It's not plain x. Can anyone give it a shot? What do you think? And just remember, the correct answer here should be this. Why don't I write times the inner function prime? Because it's 1. It's redundant. Good. So mimic this and tell me what to write. What do you think? And then we'll apply it in equations, in applications. I'm opening on page 210 already.
Is it e function times function?
E to the function times
X? Function of X? Derivative of X?
there is no x here.
Of the function.
So do you remember what we
Derivative
said?
of the function.
So please remember what we said. Times the inner function prime. If you forget this, like some of you did, and we'll talk about that in a minute on the test, you forgot the inner function prime, and that's incorrect. So then what is the correct formula?
Oh, would it be? Give me a second. I just looked into this. Would it be 6x squared? Oh, 6x squared times.
This was just an example.
X.
This was just an example.
Oh.
Just to make sure that you understand that f is not x. F is anything else. So can anyone help us finish the formula? What do you think? I wrote it here. So what is missing here?
The 1 for prime.
The prime. Excellent. That's it. So e to a function prime is e to the function times the function prime times the inner function prime. It's exactly the same formula. Here we have to omit this because it's 1, but here I cannot omit it because it's not 1. Awesome. So I'm going to share my screen. And let's pick. We want to practice from 1 through 24. This is the second derivative. We're going to choose something from here. They get very hairy, but we should choose one and determine the second derivative. So let's choose from 1 to 24 first. If you don't want to choose, I will.
We'll do 13.
13? Very good. Awesome. And I'm going to choose 15 as well. So 13 is f of x equals e to negative x squared plus 8x. And the other one is y equals the square root of e to the x minus 1. Perfect. Good. Awesome. So we want to differentiate f of x e to negative. So as you see, this is the function. This is this piece. So can anyone help with f prime of x? It's okay if you're wrong. We're just discussing this right now. Give it a shot. It's okay if you're wrong. No one? No one is courageous enough?
Would it be e to the negative x squared plus 5x?
Yeah, it's 8. I'm sorry.
Oh, sorry. times the negative x squared plus 8x.
But it's f prime.
Would it be negative 2x plus 8?
That's it. Done. Thank you. Very good. Okay, let's look at y prime. Let's try y prime. It's okay if you're wrong. Anyone? Anyone? First of all, we have to, yes, go ahead.
Square root of
Careful. We differentiate the square root. Can anyone
Oh.
remind us how we differentiate the square root?
exponent is 1/2.
Yes, 1/2 the square root of whatever
E
times
x minus 1 times x minus 1.
it's e to the x minus 1. We have to differentiate this.
So it just times x.
Let's go back. E to the x prime is the easiest function on the planet to work with.
Oh, it disappears. Okay. So
Wouldn't it just be e to the x?
That's it. Done. Thank you. Nothing else. Comes the inner function of prime, which is e to the x. Awesome. I'm sharing my screen. Let me know if you want to practice anything else. Maybe we should practice a ratio and move on. I'm going to stop my